Today, we're talking about our last chapter in 9.6, and we have a couple different things that we're going to be using to talk about that. So if I can have you all take a second and get out your Evaluating Inverse Trig Functions flipbook, or your foldable, and your Trigonometry flipbook. We will be alternating back and forth between the two of them today, and you will also want a calculator. So I'll give you a couple seconds to get those up. Okay. While you're getting those out, I want to do just a brief little review of the past couple class periods. So on Tuesday, we talked about our three main trigonometry ratios. Who can tell me what they are? Feel free to send them in the chat or say them out loud. Yeah, very nice. See it from a couple people in there. So we're looking for sine, cosine, and tangent. Those are our three main trig ratios. And our trig ratios we put in an angle. We put in angle, and it spits out a side. Or sorry, it spits out a ratio. Today, we're going to learn how to reverse our trig functions. And to do that, we are going to talk about inverses. Can anyone take a guess as to what an inverse is? So if I said to you, it finds an angle. Okay, very nice. Yeah, we will use our inverses to find an angle. So let me ask you this question. What is the inverse of multiplication? How do we get rid of multiplication? Feel free to shout it out or message it in the chat. Very nice. So I see it from a couple people now. Division. So inverses undo things. And we are going to talk about our inverse trig functions. So these are going to let us cancel out our trig functions. And we're going to work a couple different examples of these, and we'll work quite a few examples today. So starting in your yellow foldable, we are going to open it up. And then on this middle page, or on this page here, if we don't open it all the way, we have our three trig inverses along the side. And we're going to talk about these one by one. The first one we're looking at is sine to the negative 1x. I will also call this inverse sine, and I'll move back and forth between them. So what this one says, if sine of A equals x, so this is going to be a angle, and x is going to be our ratio. Then the inverse sine of our ratio will give us the angle. So with sine, we take an angle and we spit out a ratio. With the inverse sine, we take a ratio, and we spit out an angle. It just works the other way around. Let's look at an example here. So on the left, we have sine of B equals 0.87. And we want to find the measure of angle B. So, and Centrice, I just got your message. Does this look bigger for everyone? Is this okay? Awesome. Okay. Perfect. So we have the sine of B equals 0.87. And we need to find a way to get rid of the sine. So what we're going to do is we are going to take the inverse sine of both sides. So we're going to say the inverse sine of sine of B equals the inverse sine of 0.87. Our signs on the outside here are going to cancel out, which means that the measure of angle B is approximately the inverse sine of 0.87. This is where you're going to want a calculator. So I'm going to put my calculator on the screen here. If we want to type in the inverse sine of 0.87, it'll be a little different for every calculator, but the basics are still the same. What we're going to do is we're going to start by hitting second. And then if you look above the button you use for sine, it's pretty hard to see on mine, but in little blue writing, it says sine to the -1. You're going to hit that button. And then you want to type in whatever's on the inside. So in this case, it would be 0.87. You can close the parentheses and hit enter. And I got 60.45. Can you send me a thumbs up or let me know if you also got that when you typed it into your calculator? Perfect. Okay. Since it doesn't tell us how many decimal places we want, I'm only going to round it to the nearest whole angle. So we're going to say this is about 60 degrees. And that's our answer. We're going to do the same process on our next example problem here. Sine of A equals 12/13. Just like we did last time, we're going to start by taking the inverse sine of both sides. So the inverse sine of the sine of A equals the inverse sine of 12/13. Our sines cancel out, which means that the measure of angle A is approximately the sine of 12/13. And then we're going to plug that into our calculator as well. So the important thing to remember here, we can put in the inverse sine the same way, but we want to do this all in one step. So we're going to take the inverse sine of 12/13 all at once. And when we do that, we get 67.38. Did anyone else get that? Flash me a thumbs up or let me know in the chat. Perfect. Okay. So we're going to say that the measure of angle A is approximately 67 degrees. Okay. So we've done kind of these isolation examples. Let's work a couple that take a little bit more steps. So if I can have you grab your green flip books, and we are going to open them to the sine chapter, and we are going to work example 3. On example 3, we're told, let's solve for x. So I'm doing this, and I notice this time, x is an angle, right? And we don't like that. What trig ratio do you all think we should use with x? Message it in the chat or shout it out. Yeah, very nice. So I'm seeing it from a couple different people. The trig ratio we're going to want to use is sine. And we choose sine because we notice we've gotten a hypotenuse. And the side and the other side we have is opposite our angle. So we're going to say the sine of x is equal to opposite leg over hypotenuse, which means the sine of x is equal to 9/14. We're then going to take the inverse of both sides. Our sines are going to cancel, and we're going to be left with x equals the inverse sine of 9/14. Take a second, plug this into your calculators, and message me in the chat what you get. We will go to the nearest angle on these. Nearest degree. Awesome. Yeah, so I'm seeing it in the chat from a couple people. Our answer is x is approximately 40 degrees. Yes, absolutely. I can repeat how we put it on the calculator. So what we're going to do is you are going to hit your second button, and then you're going to hit sine. So when you hit second and sine, it'll pop up with sine to the -1. And then you can put whatever we have on the inside there. So ours was 9/14. You can do 9 divided by 14. Make sure you close your parentheses. You hit equal, and you're done. And again, we're using approximately here because we are rounding. Now we've talked about inverse sine. So we're going to start looking at our inverse cosine. Moving back to the yellow foldable. We're going to say if cosine of A equals X, then the inverse cosine of X equals the measure of angle A. So we use the inverse sine to cancel sine. We use the inverse cosine to cancel cosine. Let's work a couple examples of this. Our first one is cosine of C equals 0.15. We're going to start by taking the inverse cosine of both sides. Again, our cosines on the left side cancel, and we're left with C is approximately the inverse cosine of 0.15. To plug this into our calculator, it's going to be pretty similar. The only difference is instead of hitting second sine, we're going to hit second cosine. And then that'll pop up our cosine -1. So type cosine -1 and then 0.15. And let me send your answer in the chat to the nearest degree. Awesome. So I'm seeing 81 a couple times. Is everyone else getting 81? That's what I had as well. Perfect. So we can say that the measure of angle C is approximately 81 degrees. Let's try this next one. We've got another cosine to cancel. So we're gonna cancel that by taking our inverse, cos -1 cosine of B equals the inverse cos of 91 over 109. Cosines on the outside cancel, and we're left with B is approximately the inverse cosine of 91 over 109. Take a couple seconds, plug that into your calculator, and once you get something, message it in the chat. Okay. Yep, I see it from quite a few people. The answer we're looking for here, it's approximately 33 degrees. Now, if I could have you all move back over to our green flip book, we are going to be working problem number 10. It should look something like this. Awesome. Take a couple seconds and on your own, try and come up with the equation that you want to use. Once you come up with an equation, message it in the chat for me. And remember, I'm looking for the whole equation here. So I want to see your trig function. I want to see your fraction, the whole deal. Okay. So one of the things that I saw messaged in the chat to me was that we need to be using cosine or CAH for our cosine adjacent hypotenuse. So we're going to start with our equation, and we're going to say cosine of x equals, our fraction needs to be adjacent over hypotenuse. So we're going to look down at our triangle and say, what leg is adjacent to x? Our 19 is. We're going to say cosine of x equals 19, and then 24 is our hypotenuse. We're then going to take the inverse of both sides. On the left, our cosines cancel. And we're left with x equals the inverse cosine of 19 over 24. Once we get that inverse cosine, we plug it into our calculator and take a second, and then message me what you get once you plug it in. And we're rounding to the nearest degree. Awesome. So I see it from a couple people here. We're getting x is approximately 38 degrees. I saw one person message 37. So the decimal place after our degree sign was a 6, 37.6. And we got to remember with our rounding rules, if the number after the decimal is greater than 5, then we round up. Or greater than or equal to 5, then we round up. So that's why we round up to 38 and not down to 37. Okay. We are going to move back to the yellow foldable. And we're going to talk about our last inverse tangent. And what this one says, if tangent of A is equal to X, so if tangent of an angle is equal to a certain ratio, then the inverse tangent of that ratio is equal to the measure of the angle. Okay. We're going to do a couple examples here. Our first step is we inverse both sides. Since we're working with the tangent function in the beginning, tangent of A equals 0.75, we are going to use our inverse tangent. And like we have with all the other functions, the outside tangents cancel. We're left with the measure of angle A is approximately the inverse tangent of 0.75. And what do we get when we plug that into the calculator? To the nearest degree. We can plug in inverse tangent in the same way that we did the other ones, by hitting our second key, and then you hit the tangent key. Yeah, so I see this one from a couple people. And this time we do get 37. So we're going to say A is approximately 37 after rounding. For the tangent of C, it's the same process. We inverse both sides. Once we do our inverse, the outside tans cancel. We're left with C equals the inverse tangent of 5/12. And what do we get when we put that into the calculator? Yeah, very nice. So when we plug that into the calculator, we get approximately 23 degrees. Okay, we're going to go back to the green book, or the green flip book, and we are going to work on problem number 15. In problem 15, they ask us to solve for x. So take a couple seconds and come up with an equation on your own. Let me know which trig ratio you want to use and then what our fraction should be, and message it in the chat. Awesome. Okay. I'm seeing a lot of really good stuff in here, and I'm seeing a lot of people even jumping ahead a couple steps too. The one thing that I see all of our answers have in common is that we have to use the tangent function. So we're going to start with tangent of x equals. Now our tangent function is opposite leg over adjacent leg. So if we look at our diagram, we look at our x and we say, which leg is opposite? That would be our 21. And then we look down below and we say, gotcha, 25 is adjacent. So our ratio is 21 over 25. The next step we do is we inverse both sides. And when we inverse both sides, again, the stuff on the left cancels. We're left with x equals inverse tangent of 21 over 25. Plug that into your calculators. I see a couple people have already answered me with a number, but I want to see a couple more here just so we can compare. And then once you get a number answer, message it in the chat. Awesome. Okay, I see it from quite a few people here. Once we do the calculation, we get x is approximately 40 degrees. If you did not get 40 degrees, I would check your tangent ratio. And I would also check to make sure, I would also check to make sure that you use the right trig function. Okay. That's it for tangent. And now we're going to work a little bit of mixed practice. And we're going to go back to our yellow flip book. In the middle here, it says practice. This first piece is kind of conceptual, and it says determine which angle has the given trigonometric ratio. Our first one says the sine of this angle is 12 over 13. What angle do you all think has a sine of 12/13? Take a couple seconds, and then we'll talk through it. And remember, we're looking for the angle here. So D, E, or F. One of these three angles has a sine of 12/13. I see a couple people with it in the chat. I just want to see a couple more answers. Okay, yeah. So the way I would approach this problem, I see quite a few right answers, quite a few wrong ones, and that's okay. It's a learning process. Is I would look at my different angles and I would say, let's just calculate their sines. We'll start with angle F. When we say the sine of F, we want our opposite side over our hypotenuse. So sine of F is 5 over 13. Does not work. Let's try the other one. Sine of E equals our opposite side of 12. That's promising. Over our hypotenuse of 13. That does work, right? The sine of the angle is 12 over 13. Put a check mark there. And we can say that E, angle E, is our answer. Let's try the same process for problem number 2, where the tangent of the angle is 5 over 12. So take a couple seconds and compute tangent of E and tangent of F. And then tell me which angle works and message it in the chat. Awesome. Okay. So I see a couple people in there with it. So yeah, if we calculate the tangent of E, we get 12 over 5. That's no good. We'll cross that one off. But if we calculate the tangent of F, we get 5 over 12. And that one does work. That makes us happy. So angle F is the angle that works. Awesome. Let's take a look at our next piece of practice. Use a calculator to approximate the measures of G, H, and K to the nearest tenth of a degree. So that means we want 1 decimal place. So take a couple seconds, or take a minute or so, and try these on your own. And once you get an angle measurement for each one, message it to me in the chat, making sure you label which one it goes to. Awesome. Okay. I see it from a couple people in here. So on G, which inverse are we using? Sine, cosine, or tangent? Which inverse? Yeah, very nice. So we're going to use our inverse tangent on this one. We can just say that G is equal to the inverse tangent of 0.43. Notice that I'm skipping a step here. You don't need to show taking the inverse of both sides. I just showed that so we can be super precise at the beginning. And this means that G is approximately equal to, send it in the chat. I already have answers from a couple of you. I just want to see a couple more. And we're rounding to the nearest tenth of a degree. So we want 1 decimal point after, or 1 decimal place after it. Yeah, very nice. So we get G is approximately 23.3 degrees. I saw a couple 23.2s. Oh, and I see one of them just fixed it. So make sure that we're rounding and not just cutting off after that last decimal. For problem H, we have to use our inverse sine. So we say H is equal to the inverse sine of 0.68, which means H is approximately equal to, message it to me in the chat. And I've already seen a couple of you send it. I just want to make sure, see a couple more. Perfect. Yeah, so I'm seeing it from quite a few people now. Thank you everyone for participating. Makes my job a lot easier. When we plug that in, we get 42.8. Awesome. Our last one, we've got to use inverse cosine. And what did we get when we used our inverse cosine? Message it to me in the chat. Perfect. Okay, see it from a couple people there. All of these should be labeled degrees too. I forgot to include that. But this should be about 19.9 degrees. So, nice job, everyone. Very nice. Okay, we're going to go back to the green book one more time for just a little bit more practice with these. And we're going to do some word problem practice. The first one we're going to work is number 29. Caitlin's mom is standing at the bottom of the water slide waiting for Caitlin to slide down. If the slide is 40 feet from the ground and the slide is 48 feet long, what is the angle of elevation from Caitlin's mom to Caitlin? Awesome. So we are going to, first things first, we draw a diagram, right? We get Caitlin's mom right here. Got our slide. And we got little Caitlin up at the top here. We know from the problem that our slide, that the top of the slide is 40 feet from the ground. We can say that this leg is 40 feet. We also know that the slide itself is 48 feet long. So what we need to do is we need to find our angle of elevation, which is right in here. Take a couple seconds and think of what equation you'd want to use. Once you get an equation, message it to me in the chat. Awesome. So yeah, seeing a few equations in there. So what we notice is that we're solving for an angle and we have the opposite side and the hypotenuse. So that makes me think sine. We say sine of x equals, sine is opposite over hypotenuse. And yeah, very nice. So we're going to get 40 over 48. We're going to then take the inverse of both sides, which means we're going to get x is equal to the inverse of 40 over 48. And what do we get when we do that? I see a couple people's answers in here. I just want to see a couple more. Very nice. So x is about equal to 56.4. And I didn't super specify if we were still going tenths or not. So I would have taken 56 or 56.4. Either would have worked perfectly. The last step is we make sure we put our answer in a sentence. So that would be like the angle of elevation from Caitlin's mom to Caitlin is 56.4 degrees. Okay. The last problem we're going to work from the green flip book. We are fast approaching the end of the class today, I promise, is problem number 34. Michael is standing on the top of the bleachers watching the football team play. He spots the team mascot on the field. If the bleachers are 40 feet tall and the horizontal distance is 68 feet, what is the angle of depression from Michael to the mascot? First things first, we want to set up our diagram. That's going to be, so we've got our bleachers here. We've got Michael standing on the top of them. And then we've got our mascot down here. We know that our bleachers are 40 feet tall. And we know that the horizontal distance is 68 feet. And we need to find the angle of depression. This one's a little trickier because remember, our angle of depression isn't either of these. Our angle of depression is right in here. So what I notice is if I complete this down, then I form another triangle, another right triangle too. And we notice that since these are both right angles, these two sides have to be the same. We can say that this is also 40 feet. And since these are right angles, these two sides are the same. Which means we've got 68 feet up here. So take a couple seconds and try and come up with a trig equation to solve for our variable x. Once you get that equation, message it in the chat. Awesome. Okay. So what I'm seeing from the chat is we realize since we have an opposite side and an adjacent side, we need to use tangent. So we're going to say the tangent of x is equal to, and then we notice, across the figure for opposite, that's our 40. Our adjacent side is the 68. So what we can do is we can take the inverse tangent, and we get x equals inverse tangent of 40 over 68. And what do we get when we put that in our calculator? Yeah, very nice. We get x is approximately 30.5 degrees. So I noticed in the chat, a couple of you had the ratio, flipped around, the 68 over 40. So make sure, if you're still struggling with that, go back and take a look at the first few pages in the flip book, the ones that we labeled sine, cosine, and tangent. Those will have your formulas on them, and that would be a really good study tool to use in preparation for the test. Reminder, we do have a test coming up next Tuesday for you all. The test will be on Tuesday for you. So make sure you're studying for that over the weekend. We have the practice test posted online, and you will be, and you're remote, so you can use your notes for that. So we've got one last topic to cover this chapter. And if you give me just a second, I'm going to pull it up. It is not on either of our flip books. And I wanted you all to have a nicer visual that you could look at when you're doing these things. If you give me just a second to pull it up, I will use that, and then I will share my screen. Okay. Can everyone see my PowerPoint slide? Flash me a thumbs up if you can see this. Okay. Awesome. Okay. So our last topic of the chapter is solving right triangles. When we say we solve something, it means that we want to know everything about it. We want to know all the sides. We want to know all the angle measurements. Every piece of information we want to know. We have a couple tools we can use. One of them is our Pythagorean theorem. The Pythagorean theorem, we need two sides, and it solves for the missing side. The next piece is the triangle sum theorem. The triangle sum theorem says that all the interior angles of a triangle add up to 180 degrees. So to use this one, we need two angles, and it lets us solve for the missing angle. Our final tool are the trig ratios and inverse trig ratios we used. We just learned about those these past couple weeks. Our trig ratios, we need a side slash angle. So we either need a side and an angle or a side slash side. I'm going to kind of shrink this one down a little. And it lets us solve for a missing side or missing angle. Some other information. Do not use a calculated answer for two reasons. When we're doing these problems, you're typically going to be doing 3 calculations. And we have a couple reasons why we don't want to use that, a middle answer. One of them is that if we use a calculated answer and we rounded, we get round off error. Round off error is what happens when we round an answer. It's just that simple. We introduce a little bit of discrepancy. If you use an answer that you rounded again, then before the calculation even starts, you have a little bit of error in your result. And we don't like that. So we want to avoid that whenever possible. The other reason, and the much more important reason, if you get an answer wrong and you use that answer again, that unless some math miracle happens, it's going to hurt your next result. If I calculate 50 for angle A, and angle A is actually 51, then everything I use angle A for is going to be off. Guaranteed. So the important thing here is that once you get an answer, you're done with that answer. You don't have to use it again. Are there questions about this before we work an example problem? Feel free, since this isn't in any of your packets, feel free to take a screenshot of this. Okay. I am going to clear my annotations and stop the PowerPoint share in 3, 2, and 1. We are going to go back to the other piece, our old notes. So let's see. Come on. Content from second camera. Okay. Can everyone see the flip book again? Okay. Our flip book has us solving right triangles. Remember, when we solve a right triangle, we get every piece of information about it. So what I like to do, just to organize my thoughts, is I like to fill out a little table. We say DF, and this is where we're going to put all the information we know and all the information we don't, and then we can fill it in with the information we need. Perfect. So I look at my diagram and I notice, we have DF of 20, and we have FE of 21. Do we have any other measurements we can fill in on our diagram? Message me in the chat if you think we've got another one. Awesome. Yeah, Antonio, what's going on? Okay, awesome. Okay, we just wanted to make sure. So yeah, exactly. We can fill in F equals 90 degrees because F is our right angle. Don't forget that one. Now we have 3 different parts we need to solve for. Let's start by solving for DE. It doesn't matter what order we go, we'll get them all eventually. How do you all think we should solve for DE? What technique should we use? Okay. Okay, so I see trig ratios in there. Oh, and I see an answer. Okay. How did we get to the answer? I see someone had DE equals 29. What did we use to get to 29? Pythagorean theorem. Exactly. So for DE, we want to use the Pythag theorem. The Pythagorean theorem. And so we can say a squared plus b squared equals c squared. DE is our hypotenuse. So we can plug in our legs. That would mean we have 20 squared plus 21 squared equals c squared, which means 400 plus 441 equals c squared. So 841 equals c squared. We take the square root and we get 29 equals c. Awesome. So we've got DE. Now we need to solve for, let's try for angle D. So I look at angle D and I think, we don't have another angle. We only have one other angle. So we can't use the triangle sum theorem. So that means we got to use inverse trig. We're going to divide it here so that we have room for the other angle. So if we're using inverse trig, I look, and remember, we only want to use the given measurements. We have an opposite side and an adjacent side. So we can say tan of D equals 21 over 20, which means D is equal to the inverse tangent of 21 over 20. And what do we get when we do that inverse tangent? Awesome. Yeah, we get 46.4. We can fill that in up here. And the last piece we need is angle E. We're going to use inverse trig again. And this time we're going to say the tangent of E is equal to opposite over adjacent equal to 20 over 21. So E is equal to the inverse tan 20 over 21. And what is the inverse tangent of 20 over 21? Awesome. Okay, see it in the chat there. We get E is equal to 43.6 degrees. And there we have it. Our triangle is all solved. I see someone in the chat pointed out that we could use the triangle sum theorem to get that last one. But what I'll remind you is since we calculated this 46.4, we don't want to use that again unless we absolutely have to. Otherwise, it might mess up a future answer. Okay. So just a quick little straw poll here. How's everyone feeling about solving right triangles? Flash me a thumbs up if you're feeling good about it. Okay. Well, we've got one more example to work. So we'll go through that real quick. And I'll talk us through this one as well. So just like we did last time, we've got our right triangle here. And we want to start by setting up our table and listing what we know and what we don't know. We've got GH, HJ, and GJ. We've got angle J, angle G, and angle H. I look at my diagram and I see, we've got GH, so let's fill that in there. We've got HJ, so we can fill that in. And then we've also got angle J, so we can fill in our last piece there, 90 degrees. You'll always get 3 pieces of information, 100% of the time on these. I'm going to start by solving for GJ. I look at GJ and I say, we've got 2 sides here. So let's use the Pythagorean theorem or its converse. If we remember, the theorem gives us a hypotenuse. The converse gives us a leg. So we're going to use the converse here. And our converse says c squared minus a squared equals b squared. That means 109 squared minus 91 squared equals b squared. Which means, and these are big numbers here, but that's okay. 11,881 minus 8,281 is equal to b squared. which means 3,600 equal to b squared. And once we take the square root, we get 60 equal to b. We can record that in our table. Now I'm going to divide our section here. And we need to solve for angle. Let's solve for angle G next. How could we solve for angle G? Message me a couple ideas in the chat. Exactly. Yeah, we're going to want to use a trig inverse. So I look at angle G and I see, yeah, very nice. We're going to want to use sine because we have our opposite side and our hypotenuse. So we're going to say sine of G equals 91 over 109, which means G equals inverse sine of 91 over 109, which is approximately 56.6. Exactly. Very nice. We can record that in angle G right up here. And now we need to get angle H. Now remember, we can't use our G value that we just calculated, and we don't want to use this GJ either. GJ. Make sure we're putting our degree sign on everything. So to solve for angle H, we want to use trig inverses again. We're going to say are we going to use, yeah, we're going to use cosine this time. Yeah, very nice. So the cosine of H equals 91 over 109, which means H is equal to the inverse cosine 91 over 109, which means H is approximately 33.4 degrees. Now that we have all of our measurements solved for and accounted for, we are done. That is the end of material for chapter 9. Just a quick recap, solving right triangles. This uses everything that we've used so far this chapter. So make sure that you're reviewing all of your tools and being sure that you're being careful with your process to get there.